So we know that the second law of Newton is dp by dt, right? Where p is the momentum. So we will talk about the momentum little bit. So what is momentum? Anybody knows? Anybody? Xavier, what is momentum? Quickly you have to reply. If you don't know, you should say, I don't know. Interact. What is momentum, Shreyata?
Mass into velocity.
Yeah, so mass into velocity, that is correct. So now the question arises, why why do we need to worry about this mass times velocity? What does this signifies physically? So see, if I tell you a truck is moving with some velocity v and a man is moving with the velocity v, right? And if I tell you differentiate between these two, will you be able to differentiate? No, right? Because they are moving with same speed, right? So to encounter like how much energy is associated with each of them, this has a lot of mass, this has less mass, so we brought the mass into picture. We multiplied these two quantities to make some physical significance. Well, if I know the mass and velocity, I can tell how much momentum it is carrying. Okay, so to move this capital M with V and to move this small m with V, it is easier to move the small m than the capital M. You all know, right? So that's why the mass also it's very important, that that tells you like how much energy you need to invest to move these two objects, correct? So of course you need a lot of energy to move this truck with the same speed as the man moving, right? That's why, so this product has some importance, right? Now again, this is a vector quantity. Okay, so you have to use vector laws whenever the momentum comes. This momentum also has some x component, some y component, some z component. Okay, you can break it also in x, y, and z. And the direction of the momentum is always along the velocity. Okay, guys. So now, as f is equal to dp by dt, from here you can write d by dt of mass into velocity, correct? Now, there is this product, right? So we know for product how to differentiate, guys. M into dv by dt plus v into dm by dt. Here, any doubt, Xavier, Samita, and Shweta? Any doubt so far?
No doubts.
No doubt. Okay, so let us say the mass is also changing in case of rocket. Okay, if I consider the rocket, what happens as it is going up, it is leaving the fuel behind, right? So the mass of the rocket is decreasing. In this case, the mass is also changing, right? So wherever the mass changes, you have to use this formula, complete formula. If the mass is not changing, then dm by dt is 0. If mass is constant, then you can say f is equal to m into dv by dt, because this term becomes 0. Understood? If mass is constant. Okay, guys? All right.
Yes.
So, all right, let us solve some questions. Let's say there is a block of mass 5 kg, which is, let's say it is resting on a frictionless plane. There is no friction, and which is resting on a plane. Okay. Now, it is struck by a jet, releasing water at the rate of, let's say, 3 kg per second, emerging with a speed of 4 meter per second. Calculate the initial acceleration of the block. So what is happening here is you have a jet from where water is coming and hitting this block. Okay, like this, like this. Okay, so the water is coming with speed. It is coming with the speed, you know, with which it is coming is 4 meter per second. Okay, all right, and releasing water at the rate of 3 kg per second. That means that each second the amount of water coming out is 3 kg. Okay, that means the rate of mass flow, right? Dm by dt is 3 kg per second. Any doubt here?
No, sir.
No doubt. So here, tell me, is the velocity varying? I want the force. I want the acceleration of the block. To calculate the acceleration of the block, I need force. Force by m, right? So now I want to calculate the force. Correct? We know that F is equal to m into dv by dt plus v into dm by dt. Correct? But the water which is coming out, it has a constant speed. That means this term is 0. Right? Plus, what is V? It is 4. What is dm by dt, guys? 4 times 3 kg per second. So 3. So this is 12 Newton. This is your force. So what will be the acceleration? F by m. So A is equal to F is how much, guys? 12 divided by mass is 5 kg. So from here, you can get 2.4 meter per second square. Good question. Any doubt? Please
No,
note
sir.
down. Yes. Let us talk about something called a new quantity, which is impulse. Okay. What is impulse? You guys are watching this cricket IPL. Anybody watches cricket? Xavier, you do watch?
No, sir. I don't watch cricket.
You watch what, football?
Yes, a football and race.
Yeah. Okay. No problem. So see, you guys at least have this idea when a bowler throws a ball with a speed like 150 kilometer per hour, 140 kilometer per hour, you know, the speed with which the ball is coming is very, very high, right? So imagine when it hits the bat, how much force is being acted on this bat. It is huge force, very large force, correct? So can we talk about that force? No, we cannot talk about that force because it's very big, infinite. It's very big force, and that force is acting on this bat for very little time dt. Correct? The force on this bat is immediately hits back. The force which was acting on the bat was for very little time dt, and the force was F, right? And it is very large, right? F is very large, dt is very small, correct? So when you multiply a very big quantity with a very small quantity, it becomes a finite quantity, correct? Am I correct, guys?
Yes,
Shreyuta, Samhita, please speak out. I will not repeat saying please reply, okay? Am I correct or not?
Yes, sir.
Yes, sir.
So when you multiply very large number, let's say 10,000, this number has no sense. But when you multiply it, it's a very big number. When I multiply it 0.001, this becomes a finite quantity, right? That's why we brought the picture of impulse here. So if I multiply f dt and if I integrate, let's say that the force was acting from t1 to t2 from 1 second to 2 seconds, like that. So then this becomes impulse. This is nothing but impulse. Okay, so impulse, you know, F is equal to dp by dt. So from here, f dt, if I do, what I will get? Dp. So integrate on both sides. So this is nothing but impulse. Impulse dp means change in momentum, final momentum minus initial momentum. So impulse is also equal to final momentum minus initial momentum. Okay.
Yes, sir.
Okay. All right. Now we'll talk about law of conservation of linear momentum now. This you noted, right? Law of conservation of linear momentum. LCLM, not LCM. Okay. So we know that F net is equal to dp by dt, correct? So if I say that the net force on a system is zero, if I say that the net force is equal to zero, that means my momentum should be constant, right? Correct?
Yes, sir.
That means I can say P should be constant. If P is constant, that means whatever the initial momentum of the system should be equal to the final momentum. There should not be any change. So let's say there are n number of momentum vectors. Let's say there are many particles having different momentums. So you sum them all, P1 plus P2 plus P3, all whatever the momentum we have, P4 and so on, should be equal to constant, correct? It should not be varying with time. Otherwise, if the momentum is varying with time, then the force will come into picture. The force has to be zero. Okay. Any doubt, guys?
No, sir.
No, sir.
Okay, very good. And let's say sometimes simple questions comes like this. So they will give you the P versus T graph, momentum versus time graph. If they give momentum versus time graph, let's say I'm giving like this, then the slope is nothing but dp by dt, correct? This is my tan theta, right? Y by x. So any point, at any point you want to calculate the slope, you just draw a tangent, you calculate how much angle is there, you just calculate tan theta. That will give you the force, because dp by dt is nothing but force. So whenever pt graph is given, you calculate the force, you will get the momentum, sorry, force. But if f versus time graph is given, force versus time, and you know that f dt is equal to dp, correct? So integrate both sides. So if you integrate the force versus time graph, you will get change in momentum. Okay. For example, let's say something, the force is varying like this. So you calculate the total area. Okay. That area will be equal to the change in momentum of the particle. Okay. Any doubt?
No, sir.
No, sir.
Okay, all right. Note this down. I taught you all. Okay, I covered everything. You have to be like bit careful while writing equations. Use basic things that I taught you. Okay, while solving questions. Let us do some questions. Directly, we'll jump into some exam questions and we'll do it. Okay, guys. Are you guys able to see my screen?
No, sir.
Just a second. Yeah, try this second question. And did we do this question before? I think we did, right? A cricket player catches a ball of mass 120 gram moving with this much. If the catching process is completed in this much and magnitude of force
Yes, sir.
exerted. We did, right?
Yes, sir.
Okay, let us do something different. This one I gave you homework, no? You guys did? You don't do. Okay, no problem. Okay. Let us solve this. Okay, third question, try. Try fast. Simple. Write three equations, three unknown, two unknowns. Calculate. What are T1 and T2? Draw free body diagram, write equations, tell me the answer. Xavier,
Yes, sir.
be active, man.
Yes, sir.
You have to do a lot. Put
Yes,
pen
sir.
on paper, solve it, get me answer. Well, everyone tell me one equation. First, Shreyuta, tell me what will be the equation for 2 kg. Tell me force acceleration relation. Shreyuta, quickly. What is the supporting force for 2 kg?
80 Newton?
What is the opposing force?
T1 and T2.
No, which is in contact that will affect. Remember this. Whichever you see, when I say the force is acting, it should act on the body. T1 is not at all related to 2 kg. Correct? It should touch the body. That you remember always. Now tell me what is the opposing force for T2 for 2 kg?
T2.
So what will be the net force?
80 Newton plus T2 is equal to 0.
Minus T2. See, 80 Newton is supporting. T2 is opposing, right? So 80 minus T2 is equal to mass into acceleration. 2 into A. Correct? Correct or not?
Yes.
Yeah, now Xavier, tell me for 3 kg. What is the supporting force for 3 kg?
T1, sir.
T1 is supporting. Who is pulling that 3 kg block from forward direction?
2 kg, 2 kg. T2 is pulling the block forward.
Yeah, then use common sense. So what is opposing?
Opposing is the T1, sir.
So what will be the net?
Net will be
T2 is
8.
supporting. T1 is opposing. What will be the net then? Man, if someone is pulling you with 100 Newton front and someone is pulling you back with 80 Newton, what will be the net force on you?
20, sir.
Then here what it will be?
3. No.
T2 minus T1.
1.
Yeah. So
Which
T2
is
minus T1 is
3.
the net force. Net force equal to mass into acceleration 3 into A. For Shreyuta, the equation is
64.
F minus T2 equal to 2 into A. For Xavion, it is T2 minus T1 equal to 3 into A. Samhita, tell me for A block.
So T1 minus T1 is equals to 5s.
Very good. So solve now 3 equations. Tell me the value of T1 and T2. All of you fast.
So T2 will be 64.
What will be T1 then? There is only one.
Or 40. Option A.
Correct. All surfaces shown in the figure are assumed to be frictionless and the pulleys and the strings are light. The acceleration of the block of mass 2 kg is. Tell me fast. Calculate. This one I will solve. I know you guys will not going to solve because you are not working hard. If you do like this, what will happen? 4 kg. Then we have an inclined plane here with a pulley like this, and we have some 2 kg, whatever it is. This angle is 30 degree, correct? And see, always remember in this the whole string will having tension T, right? T, correct? So what
Yes.
will be the tension in this? It will be 2T. Here if it is T, here it is T, then it will be 2T. Correct? Then only the string will not break. Make sense, no? So if you see diagram, here it will be T, here T, here it will be 2T. So where I was, yeah. So see, here it is T, here it is T, here it is 2T. Okay, let us say the block is moving down and this block will move up, correct? Making sense?
Yes, sir.
Yeah. So let's say this is, if this moves down with A, it should have to move up with A. So tell me what is the supporting force for 4 kg? It is mg, right? So mg is 4g minus what is opposing force? 2t is equal to 4 into A. One equation. Second equation, supporting force for this block 2 kg is, that is 2 kg only, right? Yeah, 2 kg. So supporting force is how much? T. What is the opposing force? I told you guys, always along the inclined plane you have to write mg sine theta, and opposite to that you have to write mg cos theta. So along this length, what is the opposing force? Mg sine theta. M is 2, G sine 30 degrees 1 by 2, correct? Is equal to 2 into A. Can you solve and get the value of A for me? Solve
Yes.
these two.
So is it 5 by 3?
A is equal to, no, G you keep as it is. In terms of G, you tell me.
Then so it will be G by 3, no?
There is G by 3. Let me check. Yeah, G by 3 is the correct answer. Simple, right? Take the screenshot of solution if you want.
Yes, sir.
So I covered momentum, impulse, and some questions based on this, right? So let's see more questions. The position after a particle rate time is given by the direction of the net force experienced by the particle is. Can you guess? To calculate the direction of force, what you have to get? Acceleration, right? So here position is given, differentiate it once, you will get velocity. Differentiate again, you will get acceleration. Calculate, differentiate 2 times.
So positive y axis.
Yeah, correct. Simple one to us. Okay, all right. So the most of the theory I have covered. Okay, so there is like a small portion is remaining that I will cover in next class. But you will be having one exam. Okay, tomorrow you attend. I will upload the exam. Okay, check your understanding, how much you have understood. Okay, guys.
Okay, sir.
Yes.
Yeah. So do it and please revise whatever I have taught you so far. Watch my lectures again from the beginning if you are not understanding anything. But please please join on time and do homework, whatever I'm giving, attend exam. Do practice some questions, bring doubts. You're not at all bringing doubts. Okay. Any other concerns you have? Shreyuta, how is your study going on?
It's going well, sir.
You are able to solve questions?
Yes, sir.
Okay. What about you, Samhita?
Yes, sir. I'm practicing the PYQs.
Very good. If you have any doubt, you anytime 24/7 you text me. I will reply whenever I get time free.
Yes,
Okay.
sir. Yes, sir.
Please, I want you guys all to be successful. Coming era is very difficult. Let me tell you. The artificial intelligence is coming into picture. Getting job will be not easy. Okay. Keep that in your mind. If you want to live life like a king or something very beautiful life, please study now itself. Okay, guys?
Yes,
Yes.
sir.
Okay. All the
Yes,
best.
sir.
Then I'll see you in tomorrow's class. Okay.
Yes.
Thank you,
Bye.
sir.
Thank you, sir.
Welcome.